So in this video we're going to still be working on double angles, but one of the examples we're going to do is how to express a double angle as a single angle. So for example here we have cos 2 theta equals 7 over 25. Find the values of sine theta. Or later on we're going to do a video where it's sine of 2a or sine of 2 theta is equal to tan. So you're writing a double as a single. So now if we go back to our log tables and we try to find a connection between cos of a double angle to a sine of a single angle, we can look at this section here. That's the only one, the cos of a double angle. Now it has cos squared, which could be a bit of a problem, but we also have sine squared. Now because we know that cos squared is 1 minus sine squared, we can just replace it and move it around. So that's the formula we're going to use. So cos of 2 theta is actually, from the log tables, cos squared theta minus sine squared theta, which is grand. Cos squared is 1 minus sine squared, so 1 minus sine squared theta minus sine squared theta. 1 minus sine squared is minus 2 sine squared. So now we've written cos 2 theta in just sine thetas. Now as I explained in the last video, sine squared is the same as sine squared theta is the same as sine theta squared. So it's an easy manipulation to work it out. So now we know this is our angle here. And they've also told us the cos of 2 theta is 7 over 25. So this now equals 7 over 25. So 1 minus 2 sine squared theta equals 7 over 25. And now it's just a basic algebra question. 2 sine squared theta equals 1 minus 7 over 25. Okay, so all I've done is I brought this, the sine squared part, across to make it positive. I brought this backwards to make that negative and just rewrote it backwards. So by continuing down through the rest of this equation, we get 2 sine squared theta equals 18 over 25. Now 2 sine squared theta is this, so we want 1 sine squared theta is 18 over 25 divided by 2. That gives us 9 over 25. Now this is sine squared, which is the same as sine theta squared, which is 9 over 25. If that was an x, we would just use a square root because it would be x squared. Since it's sine theta, there's no change. It's the exact same thing. You just use the square root to get it. So sine theta is the square root of 9 over 25. Now just before we go any further, I want to point out above it says find the values. So there's plural, so there's going to be at least one case. So when you find a square root, you find the positive and the negative of it. So sine theta, the square root of 9 is 3, the square root of 25 is 5, and because it says values, you have to work out the positive and the negative. So it's positive and negative. Therefore, sine theta equals 3 over 5 or minus 3 over 5. So this next example, it asks to find sine of 2, if sine 2a is 3 over 5, find two values for tan of a. Now if we look through the logs again that we have, this is sine 2a, there's nothing that mentions tan, but if we go to the other side, there's different setups or different formulae that work as well. This one, sine 2a, has tan in it. So this is the one we're going to use. Okay, so if I rewrite that, you get sine of 2a equals 2 tan a divided by 1 plus tan squared a. Okay, so if this is equal to that one and that equals that, then this complicated, more complicated looking one has to be equal to 3 over 5 as well. So 2 tan a over 1 plus tan squared a equals 3 over 5. So now from here on out, since we've set up tan A and we've got tan squared A, which again is tan A all squared, so we have tan A everywhere, we just now have to solve for tan A to see what answer we get. A fraction equals a fraction, goes way back to our basics in algebra, cross multiply over the equals, so we get 5 multiplied by 2 tan A equals this 1 plus tan squared A comes up to the top to multiply by 3 bracket 1 plus tan squared A, multiply out and see how far we can get with it. 5 by 2 tan A is 10 tan A, 3 by 1 is 3 by tan squared is plus 3 tan squared A. Okay, now we need to try and isolate the tan squareds. So what I'm going to do is bring this 10 tan A across and then write it backwards, so it's written like we usually have it. So we've 3 tan squared A. That has come over and become a minus, and that 3 is already there, equals 0. Now this looks fairly complicated at the minute, but it's actually something that it's algebra that's disguised. We've done plenty of these before, you just don't recognize it. Now if I make a slight change, it might seem a bit easier. This can actually be written as 3 tan A squared minus 10 tan A plus 3 equals 0. That still mightn't look a bit familiar, but if I put a side note here, if I say tan A equals x, I could actually change this a little bit and say, right, that's actually 3x squared minus 10x plus 3 equals 0. Now you can see that this blue line is actually a hidden quadratic, which you've been doing for years and years and years already. So it's actually not that complicated at all. So how do we solve this? You need to factorize 3x squared minus 10x plus 3. When you factorize that out, it works out as follows. So the way I do it is 3x squared, I call it the bridge technique. 3x squared minus 10x plus 3 equals 0. We multiply the first one by the last one. 3x squared by 3 is 9x squared. The factors of 9x squared that combine to give you minus 10. So it's obviously minus 9 minus 1. So if we replace that back in, 3x squared minus 9x minus 1x plus 3 equals 0. This is just basic factorizing again. Highest common factor, 3x, x minus 3. And over here, straight away, x minus 3 equals 0. So you copy that bracket over. What number that multiplies by x gives me minus x, and the same number has to multiply minus 3 to give me plus 3, so the answer is minus 1. So now we can rewrite that as 3x minus 1, x minus 3 equals 0. We now almost have it. We have a number multiplied by a number, but I want to re-put in tan A equals x. So instead of having 3x minus 1, I'm going to write down 3 tan A minus 1 and tan A minus 3 equals 0. Okay, so now we have a number multiplied by a number to give us 0, case 1 and case 2. So case 1 is going to be this one. 3 tan A minus 1 equals 0. 3 tan A equals 1. So tan A equals 1 over 3. And our second case, tan A minus 3 equals 0. So tan A equals 3. So therefore tan A equals 1/3 or 3. Now that example did look a little more complicated, especially at the beginning when you had to translate this line to this line and then had to try and work it out. But once you get past this line here, once you get to this stage, this is just basic algebra that you've done before, using the algebraic rules we've done before, but instead of using an x, we were using tan. But the same concepts apply. You've done this loads of times before. It's just repetition and recognizing that you've done it before, which makes it a lot easier than you think it is.